Are there carbon dioxide molecules in your breath? Before we actually answer this question, let's return to experiment 7, where we saw that a gas is produced when baking soda and vinegar are mixed, and let's show that that gas is carbon dioxide. Now what we need to do is to make some lime water, and we're going to do that by taking a 1/4 teaspoon of pickling lime, which you can find in the canning section of your grocery store, and we will place it in a jar, and then we will add to our pickling lime a cup of water. And now let's secure the lid on our jar, and let's give it a couple of shakes. And as you can see, we have a cloudy solution. Now if we allow this cloudy lime water solution to stand for about 3 hours, it'll become clear like this. The undissolved lime will settle to the bottom. Okay, what we want to do now is we want to pour the clear lime water solution from the jar to a measuring cup. And we want to be very careful not to disturb the undissolved lime that's on the bottom of the jar. So as you can see, we have our clear lime water in our measuring cup, and the undissolved lime stays behind in the jar. Okay, we've made our lime water, but before we use it, let me just say that we want to avoid contact with the lime water. We certainly don't want to get any lime water in our eyes, and let's just avoid getting it on our hands as well. And the same can be said about lime. Just avoid getting it on you, because it can cause burns. Okay, let's use the lime water now to identify molecules as being carbon dioxide. What we'll do is we'll pour a 1/4 cup of lime water from this cup into this jar. All right, there's our 1/4 cup. Now we want to make some carbon dioxide molecules by mixing baking soda and vinegar. So what we'll do is we will take a 1/4 teaspoon of baking soda, and we'll add to our baking soda a 1/4 cup of vinegar. And again, we will see that a gas is produced. It's okay that it boiled over. Sometimes chemistry can be messy, but carbon dioxide is produced. We have carbon dioxide in our jar. What I'm going to do is very carefully pour the gas from the glass into our jar, but I'm going to avoid pouring any liquid from the glass. All right? So I've transferred the gas from the glass into the jar. Now let's secure the lid onto the jar, and let's shake the lime water with the carbon dioxide molecules. And as you can see, we end up with a cloudy solution. Okay. What we have performed here is a chemical change. When carbon dioxide molecules interact with the lime water, a chemical substance called calcium carbonate is formed. And the calcium carbonate is what makes this lime water solution now cloudy. For completeness, we need to show that air molecules do not undergo a chemical reaction with lime water to give us a cloudy solution. So let's take a jar and let's add a 1/4 cup of our clear lime water to it. Let's secure the lid. And now, remember, we have just air molecules with our lime water in our jar. Now let's shake our jar. And as you can see, we still have a clear solution. So this shows that air molecules do not react with lime water to give us a cloudy solution. Carbon dioxide molecules do. So we do have a way now to detect carbon dioxide molecules. We just learned that carbon dioxide molecules can be identified with lime water. Let's return now to our original question, and that is, are there carbon dioxide molecules in our breath? Let's take a jar and add a 1/4 cup of lime water to it. And now I'm going to breathe about 5 times in the jar. Now I'm going to shake the lime water with the gas that's in the jar. As you can see, the lime water becomes cloudy. This shows that carbon dioxide molecules are in your breath. Now, why are there carbon dioxide molecules in your breath? Well, it turns out your body takes oxygen atoms from the air and combines them with food molecules to obtain energy. Food molecules contain many carbon atoms, and when oxygen molecules combine with carbon atoms, carbon dioxide is produced.